Today we're going to talk about the parent functions. These 6 functions are going to be extremely important for what we're doing for the next couple days in class. So we have the 6 functions listed on the right, their names, and then you have 6 options for which equation goes with each function name. Pause your video for a minute and see if you can guess which one's which. For number 1, cube root function, you should have letter F. It's got the root and then the 3 there, it makes it the cube root. Number 2, absolute value, is letter D because it's got the lines that symbolize absolute value. Square root is our root symbol with no little number. Linear is our most basic function. It's got no extra symbols, just y equals x. Cubic function is x to the 3rd power. And quadratic function is x squared. So we're going to look at the graphs, domain, range, and end behavior of all of 6 of these parent functions. You do need to memorize these parent functions before next class. You're going to have a small quiz on it. So y equals x, we said, is a linear function. And for most of these functions, we're going to use the x values -2, -1, 0, 1, and 2. And these x values should help us notice a pattern. So if x is -2, y will also be -2. We're just going to plug the x values into the x in this equation. So if x is -1, y is -1. If x is 0, y is 0. If x is 1, y is 1. And if x is 2, y is 2. So let's plot these dots. -1, -2. Or sorry, -2, -2. -1, -1. 0, 0. 1, 1. And 2, 2. And you should notice that these dots make a line. So if we kept going, we could make more dots to fill out our whole line. Because the function goes on forever, we're going to have an arrow pointing up and an arrow pointing down on the other side. So for our domain, because we have an arrow pointing left and an arrow pointing right, our domain is -infinity to infinity. I'm going to write these domains and ranges in interval notation just because it's easier. If you like set notation better, you can do that as well. For our range, since we have an arrow pointing down and an arrow pointing up, the range is also -infinity to infinity. For our end behavior, we start out as x goes to +infinity, f of x goes to, f of x is going towards +infinity because it's pointing up on the right. As x goes to -infinity, meaning our arrow on the left, f of x is going to -infinity because it's pointing down. Our next function is the absolute value function. And again, we're going to use the x values -2, -1, 0, 1, and 2. Those will help us notice our pattern. The absolute value means the distance away from 0. So the absolute value of -2 would be 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So let's plot these points and see what it does. -2, 2. -1, 1. 0, 0. 1, 1. and 2, 2. So if you notice, it makes sort of a V shape, and if we wanted, we could continue on with our dots in those directions. So absolute value makes a V shape. That should help you remember it. Absolute value makes a V. So since again we have an arrow on the left and an arrow on the right, we know our domain is negative infinity to infinity. Our range this time, our lowest point is at 0, so our range is going to go from 0 to infinity. And our end behavior. For absolute value, both of our ends are pointing up, so both of our end behaviors go towards positive infinity. All right, our third function is x squared, which is called a quadratic function. And again, we're going to use -2, -1, 0, 1, and 2. So since these are x squareds, we're going to need to square all of these x values to get the y's. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Now, if we had -3 and 3 in our x values, what do you think our y value would be for those? If you guessed 9, you're correct, because 3 squared is 9, and -3 squared is also 9. So our quadratic functions make a U shape. Again, we have arrows on the left and arrows on the right. So our domain is negative infinity to infinity. Our lowest point is 0, so our range goes from 0 to infinity. And just like absolute value, our end behavior, both our ends are pointing up. So for both ends, f of x is going towards positive infinity. Now on to our square root function. Since we're dealing with square roots, we need to pick some different x values because there's only certain numbers that you currently know how to square root. Later on this year, you're going to learn how to square root negatives, but for right now, we're going to stick to square rooting positives. So the lowest x value we're going to use is 0. And then for the rest of our x values, we want to choose perfect squares. So we're going to choose 1, 4, and 9. This will help us in making sure that we have whole number answers for our y values. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So 0, 0, 1, 1, 4, 2, and 9, 3. Since we're not going to square root negative numbers, we're not going to keep going to the left. We're just going to have one arrow that points to the right And our graph kind of looks like an eyebrow. So our domain starts at 0 and goes to the right forever. So 0 to infinity. Our range also starts at 0 and then goes up forever. So the range will be 0 to infinity. And square root's special with end behavior. Since we only have one arrow, we're only going to have one part to our end behavior. So as x goes to positive infinity, because our arrow is on the right, f of x goes to positive infinity. All right, our last two functions are our cubic function and our cube root function. For our cubic function, we can go back to choosing -2, -1, 0, 1, and 2. And we're going to raise each of these to the third power to get our y values, which are -8, -1, 0, 1, and 8. So -2, -8. -1, -1, 0, 0, 1, 1, and 2, 8. This function is going to look kind of like a sideways S. Since there's an arrow on the left and an arrow on the right, domain's going to be -infinity to infinity. Since there's an arrow pointing down and an arrow pointing up, the range is -infinity to infinity. And end behavior, as x goes to positive infinity, f of x goes to positive infinity. And as x goes to -infinity, the arrow on the left is pointing down, so f of x is going towards -infinity. Just like with our square root, we needed special x values, our cube root is also going to need special x values. We're going to use perfect cubes, which happens to be the y values from our cubic function. If we take the cube root of those numbers, we'll get what we used to cube it. So, since -2 cubed was -8, that means the cube root of -8 is -2. Just like down here. 2 cubed was 8, so the cube root of 8 is 2. These two functions are inverses of each other, so we just have to switch their x and y values. So let's plot them and see what these look like. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Connect our dots, and it kind of looks like a flattened out S. So, since there's an arrow on the left and an arrow on the right, our domain is -infinity to infinity. Our range, technically this arrow is going down, very slowly, but it's still going down. And this arrow is very slowly going up. So our range is technically going from negative infinity to infinity. It's just a very flat function, so it does so very slowly. Our end behavior, as x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. Our arrow on the right is very slowly going up, and our arrow on the left is very slowly going down. That's all for your notes on parent functions. You need to start memorizing these. We'll have practice in class to help you memorize them, and you'll have a quiz on them class after next.